Hello my dear students, welcome to Diksha Karnataka YouTube channel. I hope all of you are doing very good. Okay, today we're going to talk about properties of definite integrals. We have already done 2 sessions on the definite integral. In the first session we talked about the very basics, we solved the very basics questions. The second session of the definite integral we talked about advanced questions on the or better questions or difficult challenging questions on the definite integral. In today's session we'll talk about the properties. Okay, what for even function, what for odd function, when can we change the limits. Okay, so we saw that as well. We'll see that in today's session as well. In the previous session I think we talked about more on substitution, right? Okay, so we'll complete our concept part of integrals in the today's session. So we'll complete in the total of 8 sessions of the integrals. Next coming up will be your revision. 2-3 sessions will complete. We'll do that only for revisions of integrations. We'll solve more and more questions. Okay, so let's start with the session right now. Take your pen and paper out. If you need to have a break, take a break, then you start the session. But if you're starting, complete it in one shot, no break in between. Have some water, take a pen and paper out. I hope you have already made the formula sheet as I mentioned for calculus. Whenever you are finding time, make your formula sheet in your own, in your own words, with your own handwriting. Don't copy and paste from someplace else, because when you're writing by yourself, you get, you get some things in your mind as well. You get some doubt as well, and when you get your doubts answered, you have full clarity, full, it's easier to remember those things, right? So make your formula sheet by yourself. Okay, do not keep one day to make formula sheet. Every day you can make little, and you'll have in few days, in a week or time, you'll have your entire formula sheet ready. Okay, so let's start with the session. First thing coming up is what, bacha? It's the properties only. So first slide we have taken for some properties of definite integral. Okay, some properties of definite integral. Let's look at them one by one. I think I've taken around 6-7 properties. First one is, okay, so this is so very simple. If the limits are the same, it means what? If you integrate it, what you're going to get? Let's say I have a antiderivative for fx as the capital of f of x. Okay, then if you put this limit over here from a to a, you'll get what? It'll become f of a minus f of a. How much is that? It's simply 0. It's simply 0. Am I right? Yes, simply 0. What about this property number 2? Okay, you can interchange the limits. Okay, so if you do it like this, for example, a to b and b to a. Okay, a to b and b to a. Please have a look. Lower limit is a, upper limit is b. Here, lower limit is b and upper limit is a. So if you take for this part, for the first part, is going to be what? F of upper limit a, sorry, not a, it's b, right? Upper limit is b in the first case. So f of b minus f of a, you will get for the first one, for this part. And what about this part? You will get for this part as f of a minus f of b. But if you put a minus sign outside, it means what? Both of these things are equal. Okay, both of these are equal because they put a minus sign. So if you are changing the limit from upper to lower to upper, just include a minus sign in the integration. That will be same, exactly same. What about over here? If you want, you can change the variable completely without changing the limit. Okay, but this is not substitution. For example, what I'm trying to say here is, let's say I'm integrating what? Sin x dx from where to where? Let's say 0 to pi by 2. Okay, I can write this same integration in terms of what? In terms of another variable like this, 0 to pi by 2 only, and write it as sin t dt. Sin t dt means I'm not changing a substitution. I'm not making a substitution over here. Just changing the variable. If you do that, it's allowed, and the limit will remain unchanged. The limit will remain unchanged. Okay. So look at here. Property number 4. We have a to b for the fx dx. I can break it n number of times. A to c, c to b. I can make again a to c, c to k, k to b. I can break it n number of times. Okay. But understand this. This function has to be same all the time, and the lower limit of the first function, first integration should be this lower limit, and the last integration should have same upper limit. What is the necessary condition? I can break this integration n times as per my requirement. Why I am doing that, sir? Because this makes at the times work easier. We'll see in the coming questions. Okay. For now, just understand I can break this integration n times, means however number of times I need to. Okay. Just provided that the first integration's lower limit should be same as the lower limit of the given question. Okay. And the upper limit of the last integration should be same as the provided in the question, upper limit. Okay. So this, if you check here, b is b, a is a. Okay. Chali. Property number 5. 0 to 2a fx dx equals to 0 to a fx dx plus 0 to a f of 2a minus x. Okay. Very important property. Very important property, very important property. Okay, I'll show you, I'll give you a proof for this, I'll explain you how this is true. So if you check here, this part is to 0 to a, only this thing is what? The difference here, f of 2a minus x. If I somehow make it as f of x, my life will be easier. Let's see, how can I do that? So I want to take this part, directly. Write this is my integration, let's say I, just for this case. I write my I as what, bacha? 0 to a f of 2a minus x, and now take the substitution as, please have a look, substitution as a t equals to what? T equals to 2a minus x. T equals to 2a minus x. Differentiated, I'll get what? dt equals to minus dx. Why, sir? Because for 2a I'll have 0, for x I'll have 1, and dt by dx will get x over here. So dt equals to minus dx. Okay, please check. Dt by dx I'll get over this side. If you are confused again, I can rewrite this step. Dt by dx I will write over here. It will be 0 minus 1. Okay, minus 1. How much that will be? Simply dt equals to minus dx. Dt equals to minus dx. Okay. Now if you put it here, what are you going to get? You will get 0 to a. Is it right? No, sir. Why not? Because whenever we are changing the substitution, we are using substitution, we have to use what? Change in the limits also. So please have a look. Have a look over here on this side. So what is my first one? X is 0, lower limit, x is 0. So my x is 0. What is my t? T is 2a minus x. T is 2a minus x. Simply what? 2a, because x is 0. Simply what? X is 0, so 2a minus x. Next one is what? When x is a. Upper limit is x equals to a. What is my t? T is going to be what, bacha? 2a minus a. How much is that? Simply a. So my upper limit has become what? A, and lower limit has become what? 2a. So I can transform this as 2a, okay, 2a to the upper limit as a, and this will become what? F of t. Why t, sir? Because 2a minus x I have taken as t, and this will become what? Dx will become what? Simply minus dt. Why minus dt, bacha? Because dx is what? Minus dx. Check here, there is a minus d sign over here. So I can take it as minus dt. Okay. Now if I do that, please have a look. So what I'm getting this as, I have taken this I equals to integration of 0 to a f of 2a minus x dx, right? Yes, equals to what I'm getting 2a to a f of t minus dt. That's what I received. Okay, please have a look. F of t minus dt. Okay. Now if you see here, I can take this minus sign outside. Okay. So I'll get what? 2a to a minus f of t dt. Okay. Now minus sign means what? I can use this property. Please have a look. Minus sign, I can interchange the limits. So a to b will become b to a with a minus sign. So I can interchange this limit as a to 2a, and this I can take this minus sign out. See, a to 2a and 2a to a, the minus sign can be taken out. This becomes what? F of t dt. This is simply what? My I. I can rewrite this as using first this property. Third property. Variable can be interchanged, x dx, f t dt. So I can swap this as a to 2a f of x dx. I'm changing just the variable without changing the limit. I'm changing the variable without changing limit. So my I value is this final. Yes or no? My I value is this. Okay. Chali. Moving on. Have a look. So this is my I value. Now I can write my condition which was there for RHS. For RHS, what was it? Please have a look. 0 to a fx dx. 0 to a fx dx plus. What was it, bacha? It was 0 to a. How much is it? 0 to f of 2a minus x. F of 2a minus x dx. This I took it as the integration I. So I can write it back as the value of I, which is nothing but, please have a look, 0 to a f of x dx plus, what is this coming as? A to 2a f of x dx. Check here limit 0 to a to a. I can write this by clubbing them together. This property says 0, okay, this property, fourth property says a to b, a to c, c to b, same thing, okay, a to b, b to c, like this, okay. This will become what? 0 to 2a, see, lower limit of the first integral, upper limit of the last integral, so 2a, the function is same, right? So f of x dx, isn't this equal to LHS actually? Please have a look. 0 to 2a fx dx, so it is equal to LHS, sir. I have proved it, okay. Now, how to remember this property? This is proved. The condition is proved, bacha. But how to remember this property? I'll tell you. Do one thing. Just remember this. Whatever is over here, no, 0. Add the limits. 0 plus 2a. How much is that? 0 plus 2a is 2a, and that will just write it like that. So, sum of the limits 0 plus 2a minus x. Write it like this. Sum of the limits, so 0 plus 2a minus x. This is what we can write this as, 0 plus 2a minus x, okay. Chali. Property number 5 is over. Property number 6, okay, property number 6. Moving on. Minus a to a fx dx, minus a to a fx dx. If the function fx is even, I can write this as simply 2 times of 0 to a fx, okay. And if it is odd, if the function fx is odd, I can write it as 0. You know the odd and even function? Even function, even if you put minus x, will come out as fx, for example, cos x, cos of minus x is how much? Cos x, mod x is also is even only. What about this? F of minus x, I can take sin x. Sin of minus x is what? Minus sin x. Sin of minus x is how much? Minus sin x. So, you see here, this is odd function. So, if the given function is odd, okay, the result will be what? Simply 0. Simply 0. But for even, I can write it as 2 times of the integration between 0 to a. So, I don't have to integrate from minus a to a. I can just integrate from 0 to a and multiply that with 2 for the even function, for odd 0. If you want, I can show you how, okay. So, let's see this condition from here. This will become what? Minus a to a f of x dx, okay. I can break this as what, bacha? Minus a to a f of x dx plus, how much is this? Sorry, forgive me, not minus a to 0, I'm wanted to write, okay. I can write this as minus a to 0, and this will become what? This will become 0 to a, same thing will be written here, f of x dx. Now do one thing, substitute x as minus t. Why minus t, sir? Because if you see here, I want to have this minus condition. So I'll take the substitution as x equals to minus t. What is my dx value? Dx equals to minus dt. Dx equals to minus dt, okay. Alright. Now, please have a look. If you do that, what are you going to get? Will the limit change? Yes. Please have a look. So, if my x is what, bacha? X is minus a. My t will be what? Minus of, because x is what? Minus t. X is minus t, it means it will become minus of minus a, it will become what? Simply plus a. Because x is minus a, so plus a. When x is upper limit, 0. X is 0. What is going to be t? Again 0. So, my limit has changed. This is my lower limit. This is my upper limit. Please have a look. Okay. So, I can rewrite this function, only this part as a, lower limit is a, upper limit is 0. This will become what? F of minus t. What is dx? Simply minus dt. Please have a look. Dx is minus dt. This is complete. What about this? This will remain as it is, 0 to a f of x dx, okay. I can take this minus sign outside, write it as a to 0 f of minus t dt. This is here what? This is simply what? Minus sign outside. Now, if you see here, plus 0 to a f of x dx. Now, very carefully have a look. I can take this minus sign and change this limit. So, I can just erase this. I'll take this as a to 0 will become what? A to 0 will become 0 to a, provided I make it positive, because the minus sign will be positive and it becomes 0 to a. Now, please check, limit is same. What about function? Can I change the function to be like this? Limit is same, right, for the integration. So, I can rewrite this thing as integration of, let me change the ink color, integration of from where to where? 0 to a, okay, 0 to a, alright. What's the first function? F of minus t is there. I can write it as f of minus x because I can change the variable keeping the limit same, no problem, plus f of x dx. So this is my final integration, okay. So initially I started from here, f of x dx from minus a to a. I got my answer as 0 to a f of minus x dx plus f of x plus dx, okay, f of x dx, okay. Now check here, for even function, f of minus x is how much? F of minus x is simply fx. So you'll get fx plus fx. Please check here. I started from the LHS condition, this condition, okay. From this condition, I have reached here 0 to a f of minus x dx plus f of x dx, okay. Now what I am saying is, for even function, f of minus x is f of x. So this will become what? F of x plus f of x. It will become what? 2 f of x integration with what? The variable dx. Yes or no? Okay. But for odd function will be what? F of minus x will be minus f of x. So this will become what? Negative. This is positive. Will become what? Sum will be 0. Minus f of x plus f of x will be 0. That's why the answer is 0. So property number 6 is understood? Okay. So I just changed this part using the properties that we have learned so far, and we got the result as, for even function we can write it as 2 times of 0 to a. For odd we can write it as just simply 0. Okay, chaliye. Last one, same property I can rewrite this as, check here, a to b is there, no, I can write it as what? A plus b minus x. Same thing I used over here also. Please check. 0 to 2a minus x, okay, same thing is over here. So I can rewrite this function fx dx as f of a to b, the limits, okay, and the same limit minus x dx. The answer will be same. Okay, we'll use this property a lot of times. We'll use this property. I think the first question we'll use on this property only. Okay, so I hope this is visible. I'll show you all the properties at once. Okay, have a look. Moving on to the first problem. Okay, chaliye. Achha, one more thing. This session is about only properties of integrals. So if the question comes from indefinite integral or different integrals on the substitution, I'll give that as homework because I've already solved those questions. Okay, so I will ask you to practice from your side and give me the answers. Okay, so I'll just try to complete this property in the today's session as soon as possible. Let's see, because if you're coming here means you're coming for what? To learn properties of a definite integral. So let's just focus on that in the today's session. Chaliye. First question, integrate from 1 to 2. The limits are 1 to 2. Root x upon root 3 minus x plus x. Okay, chaliye. पहला वाला कर लेते हैं. Part 1. Do we have enough space? Yes, we have enough space, sir. So if I'm doing the part 1, I can write this as, please have a look. If I take x as, same thing, please check. Sum of the limits, so 1 plus 2 minus x. How much is that? 3 minus x. 3 minus x. This is my substitution. Okay. Achha, one more thing. Do we change the limits and change the dx? No. Please have a look. Property number 7. Okay. Property number 7. We don't change the limit a to b, and dx also remains as it is. So no change in that property. Okay. Only I can take this directly as the sum of the limits minus the function, the variable x. Sum of the limit is what? 1 plus 2. So 3 minus x. So now look at this thing. So first I'll write this I as, this integration I as 1 to 2 root x upon root of 3 minus x, this is what they have given, plus root x dx. I rewrite this thing again, equals to 1 to 2, root x will become what? Root of 3 minus x, because I am writing x as 3 minus x, upon, this will become what? Tell me. 3 minus x will become what? 3 minus x, okay, and this will be what? Simply plus root of what, bachcha? 3 minus x. Dx will be there. Okay, chaliye. Please have a look. 1 to 2. This will be simply same thing in the numerator. 3 minus x. What about this? 3 and 3 will cancel. I'll get what? Minus and minus x. Simply plus x, plus sign. Root of 3 minus x. If I take this as my equation 1 and this as my equation 2, add them, I get what? I get 2i equals to what? So limit is same, so 1 to 2. I can add this. Take here. LCM is same. The denominator is same actually. root x plus root of 3 minus x. Over here also root x plus root 3 minus x. So denominator I can write it as root x plus root of 3 minus x. What about numerator? Will again be what? Root x plus root 3 minus x. Please check here. Root x plus root of 3 minus x dx. This whole thing is same. So cancel. What is left now? Only dx. What's the integration of dx, bacha? From 1 to 2. Simply, sir, x in the limit 1 to 2. So my 2i is equal to what, bacha? 2 minus 1. How much is that, bacha? 1. So what is my I value? 2i is 1 means my integration I value is how much? 1 by 2. What are we looking to find out? The value of integration, right? We are looking to find out this value. And how much this came as? 1 by 2. What is my answer for the first one? This answer is 1 by 2. This is my answer. 1 by 2 for the first one. Okay. Let's look at the second one. I'll solve it again. Okay. Let's see. Second one, 0 to 1 log of 1 minus x minus 1. So it's 0 to 1 log of, what is it? 1 by x minus 1 dx. Let's take this to be again my integration I. Yes. 1 by x minus 1 dx. Okay. Now what we're going to do first, same thing. We'll take the, first we'll simplify this. I equals to what? 0 to 1 log of 1 minus x upon x dx. Am I right? Yes. Now do one thing. Put what is the limit here? 0 to 1. So I can write this x as 1. So 0 plus 1, the sum of the limits, minus what? X. What is the condition? Simply 1 minus x. So let's replace this x by 1 minus x everywhere. So this will become what? This is my equation number 1. I get equation number 2 as limit will remain same, 0 to 1 only. Log is just log, simply 1 minus x is what? 1 minus x. And what is denominator? 1 minus x dx. Please have a look. So it will become what? 0 to 1. 0 to 1. 1 and 1 will go out. I get what? Plus x. Simply log of x upon 1 minus x. Okay. Dx. Yes or no? Yes or no? Yes, sir. Chaliye. Now if I add this is my equation number 2. Now add 1 and 2. So 1 plus 2 if I am adding, what I am going to get? 2i on the left hand side, 2i. Please check. I plus, this I plus I is 2i. What is this? This is my equation number 2, bacha. This is equation number 2. If I do this, I get what? Same integration is there. So from 0 to 1, I have log, so I will take this log as it is. Log of what? First one? 1 minus x. 1 minus x upon x, okay, plus log of x upon 1 minus x, okay, 1 minus x, close this bracket, dx, right? Please check. This log plus this dx, I can take it outside, okay. Log a plus log b is log a into b. 0 to 1 log of what? 1 minus x, a into b multiplied with x times of 1 minus x, okay. This whole thing is with dx, okay. Please check. How much is this? X and x goes out, this whole thing also goes out. What is the answer? 2i equals to 0 to 1 log of 1 dx. What is log of 1? 0, sir. So this is simply 0. Simply 0. What is my 2i? 2i is 0. So what is my integration? Simply 0. Simply 0. Integration is 0, right? Because 2i is 0 means I can take 2 on the other side. Answer is what, bacha? Answer is 0, sir. Answer is 0 and 1 by 2. Okay. Have a look from the beginning. Visible, sir? Yes. This is for my question number 2. This is for my part 2. Okay. Chaliye. Aage badhe. Moving on. Question number 2. Okay. Alright. How will I solve this question, sir? I have to use substitution, sir? Yes. Let's see. How can I take the substitution? Cos inverse of x, I can take it as t, sir. Differentiated, what I'm going to get? First I'll take this on the side, I'll get x equals to cos t. Differentiate, I'll get 1 equals to minus sin t dt, okay, upon dx. What is my dx equals to? Dx equals to minus sin t dt. So the substitution is over now. What about next one? Next one is changing the limits. So I take whenever lower limit is what? Whenever x is 0, whenever x is 0, what I get bachcha? I get my t value is cos inverse of 0. How much is that? Simply pi by 2. Cos inverse of 0 is pi by 2. Okay, so this is pi by 2. What about this? I get the, when x is 1, I get this as t equals to cos inverse of, how much is this? Please have a look. Cos inverse of 1. So how much is this? 0. Okay, how much is this? 0. So I can write this as from where to where? Check this condition now. This becomes what? Pi by 2 to 0. Pi by 2 to 0. This will become what? Cos inverse of x will become what? T. So I can write it as simply t square. What is dx? Minus sin t dt. Minus sin t dt. Okay, this is multiplication. I can take this minus sign out. It will become what? Minus pi by 2 to 0 t square sin t dt. I have a minus sign. I can interchange the limits. It will become what? 0 to pi by 2 t square sin t dt. Okay, from here it's your job to solve it. Solve and give me the answer. Solve and comment your answer below. Okay. Why, sir? What are you going to use here? If you want more hint, we can use by parts. Use by parts here. Very, very simple. Very simple question in by parts. See, algebraic and this is my function 1, this is my function 2. Algebraic and trigonometric, ATE, right? We have to use eyelet. Okay, so A is giving preference over the trigonometric function. So ATE, this is my function 1, function 2. Integrate using by parts and solve the question. What's the limit? 0 to pi by 2. What is the property involved here? I only did for property. Use a substitution, change in the limits. Property is what? Change in the limit by taking the minus sign for the limits, for the integration. This was minus sin t dt. From where, sir? From here. Minus sin t dt. Okay. Minus sin t dt will become what? Integration negative. I can take the negative in the limits. It will become what? Reverse the limit, 0 to pi by 2. 0 to pi by 2 t square sin t dt. Solve it from here. Have a look. If this is visible. I hope this is visible. Moving on. Question number 3. Question number 3. All right. So again, a very, very good question. We don't have to solve the integration in this case. We have to check which of the form is valid for this. Means which of the integration form will come if you simplify this going forward. Okay. So please have a look. Again, you can see here what is the property? Minus a to a, sir. Because minus 1 to 1 is minus a to a. Means I will have to use what? In even and odd functions. I have to make use of even and odd function. How will I see this? Sin x is what? Please check. So mod x is again even. So 4 minus mod will be again even only, no? This is even function. And what about this? This is again even function. So if I separate this, minus 1 to 1, I can write this as 2 sin x upon 4 minus mod x, okay, minus 3x square upon 4 minus mod x, right? Mod x, and this dx will come. Now please check here. Very, very simple. For this part, it's going to be what? 0, because odd. So this is going to be 0 completely. So I have to ignore this part. So I can write this as 0 minus, from where to where, bachcha? Minus 1 to 1. And how much is this? 3x square, 4 minus mod x dx. It's even function, right? X square is what? Even. Anything you put, it will be coming as positive only. Okay. So 0 minus, I can write this as what? Minus 2 times of, from where to where? 0 to 1. Okay. Minus a to a will become what? 0 to a. And what will this be? 3x square upon 4 minus mod x dx. Bring this 3 and multiply with this. What are we going to get? Minus 6 times of 0 to 1, 3x square, 4 minus mod x dx. Any option like this? Okay. Yes. Okay, sorry, forgive me. I've already taken the 3 out, no? There's no 3 here. How, sir? I've taken this 3 and multiplied with this 2. So 3 into 2 is 6. Okay. Chaliye. Which option is correct then? In that case, option number B looks right. B looks right. Okay. Yes. Option number B is correct, sir. Option number B is correct, sir. Okay. Chaliye. Question number 4. Question number 4. All right. So again, can you solve this? Can we solve this? Of course we can solve this, sir. First of all, even or odd? Even or odd? Sir, even function. It's a even function. It means I can write this as simply what? Please check. 2 times of, if this is my integration I can write this as 2 times of, 1 second. Let me write the I over here. So my I equals to 2 times of 0 to pi. Please understand. 0 to pi. I am making this function. Okay. Please check. If you want, I can give you the even odd function later. Right now, let's simplify this. Going from here, let's simplify this. What we can do it for this thing? It'll become 1 plus cos 4x is there, right? So I can write this as 2 cos square 2x, correct? 2 cos square 2x in the root with dx with the integration from where? Minus pi to pi, minus pi to pi, okay? I equals to what? From, please check. It'll become what? Root 2 is a constant. I can take root 2 outside. It'll become what? Integration of what? Cos 2x, okay? But with the mod, because I'm taking this root, no? So with the mod, dx, what is it? Minus pi to pi. Now if you can check here, mod is there and the cos is there. Even properties only. Sorry. So I can write this as root 2. This will become what, bacha? This will become 2 times of 0 to pi. Why 0 to pi? Because sir, this is minus a to a, minus pi to pi. So minus a to a, 0 to pi, what does it be? Please check. Cos 2x dx. Achha, one more thing. When is cos positive? When is cos positive? Please check here. Cos is positive from 0 to pi by 2. But it is what, bacha? Tell me. It is what? It is going to be your 2x. It means it will become what? Please check. From 0 to pi by 2, I have cos positive. Cos x is positive. Okay. So if I am writing for cos 2x, what will happen? It will become what? 0 to pi by 4. Why pi by 4? Because if you put here cos of 2 times of pi by 4, what are you going to get? Maximum value. You will get this value as pi by 2 only, no? So if the condition for pi by 2 is for x, this interval is for x, then what will happen for 2x? It will become interval 0 to pi by 4. Okay. And in, how much is this angle? 0 to 45 degrees. And what is this angle? 0 to pi. 0 to pi is nothing but 0 to 180 degrees. Okay. Now think about it. 0, 180 degree. First 45 will be like this. So this is my first 45 degree, second 45 degree, third 45 degree, and my fourth 45 degree. Yes or no? So basically, if I am writing the interval, why for? Because this is what? Please check. This is your required condition for cos 2x. For cos 2x, no. What will happen? Please have a look. It will become what? Root 2. So 2 is there. I can write 2 root 2, and I can write this as cos 2x dx. But in what interval is positive? In the interval 0 to pi? No. It's interval 0 to pi by 4. But sir, this 0 to pi, then should we ignore other interval? No. You can see that this will come 4 times. So 1, 2, 3, 4. This will come 4 times. I can write it as simply what, sir? Multiply this with 4. Very, very important concept. Please understand this. Okay, this is a very good concept. You have to understand this. Very, very important. Chaliye. Okay. So I have to change the interval from where to where? 0 to pi by 4. Why, sir? Because for this to be positive, this will become what? 2 will become, this 2 I have taken out already as 2 root 2. I have to include how many intervals are like this in 0 to pi? Sir, 4 intervals total. So what is this answer going to be? Simply, sir, 8 root 2 of cos 2x integration. Okay. So if I do it on this side, my question has become now 8 root 2 integration of what? From 0 to pi by 4 cos 2x dx, right? So 8 root 2 will remain as it is. Integrate this. Cos will be what? Sin 2x upon 2. Sin 2x upon 2 from what? 0 to pi by 4. Please check. So 8 root 2 sine of what? 2 times of pi by 4 minus by 2 minus sine of 0 by 2. Why, sir? Because if you put lower limit, no, 0, everything will be 0 only, okay? So sine of 0. How much is that? 8 root 2, this is the same thing, my integration I. Sine of 2 is going to be what? Sine of 2 with, this will be what? Sine pi by 2 upon 2, correct? 2 with pi over pi by 2, and this is simply what? 0. How much is that? Please check. 8 root 2 times of 1 upon 2. Sine pi by 2 is 1, right? Cancel this. What's my answer, bacha? 4 root. What is my answer? I equal to 4 root is my answer. Okay. My integration for this part is 4 root 2. 4 root 2 is my answer. Okay. Have a look. This is not part of the solution. Okay. This over here is just to explain you how the angle change we have taken place. Solution is only this condition till this part and over here. This is not solution. Not part of solution. Just for explanation part, how we are using it. Okay. If you're not sure about this also, check the graph of cos x. Chali. Moving on. Okay. Moving on. I hope this was visible, right? Yes. Question number 5. Find the value of, again, please check, minus a to a. Means I have to use the condition of odd and even again. Okay. Is this odd and even? If I break this, please check. If I take this integration I equals to minus 1 by 2 to 1 by 2. What is this? Greatest integer function. This is my greatest integer function x. Okay. Plus. Okay. Dx will come plus. Integration from what? Minus 1 by 2 to 1 by 2 ln 1 plus x upon 1 minus x dx. है ना? Correct, right? 1 plus x upon 1 minus x dx. Now, look at this. Isn't this odd function? If you take a minus sign over here, I'll give you a hint. It's an odd function, okay? This whole thing will become what? 0. I'll tell you why. Odd. The condition is odd. I'll show you how. If you take this as minus ln, no? Okay. What will happen? It will go inside. It will become what? Ln power 1 plus x power what? 1 minus x to the power minus 1. What are you going to get? Please check. You're going to get 1 minus x upon 1 plus x. Okay, 1 minus x upon 1 plus x. Okay, which will be coming as ln of minus x. Alright. So if I replace x with minus x, this is what I'm going to get, no? If this is, let's say, ln of plus x, this will be ln of minus x, no? So you can say, if I take minus sign inside, you can take it out as, minus outside. I'll repeat. You can take here minus sign inside, this can come out because I've taken minus out and taken in also. Yes, I have taken minus outside, I've taken inside like this. Okay, so you can take it out also. Okay, take it out as well. Chali. Okay, so this is odd function. Okay, this is simply sir odd function. Okay, okay, not part of the solution, not relevant to us. So this is just odd function. All right, let's see what we can do over here. Only for this part will do. Only for this part will do. So we'll do what? I equals to. Can I break this? I have to break this. Okay, so I'll do like this. So minus 1 by 2 to 0 for the same function, and what? Plus 0 to 1 by 2. Now you'll see. Now tell me, in this condition, what the function will open with from where? Minus 1 by 2 to x. The function will open with. Minus 1. Okay, it will simply become what? Minus 1. Minus 1 dx. What's the limit? Minus 1 by 2 to 1. What about this part? This will open with 0. So 0 will be there. 0 to 1 by 2. So I don't have to find this is simply 0. Okay. What about this condition? This will become what? Minus x. From where to where? Minus 1 by 2 to 1. Okay. Take the minus x outside. What are you going to get? This is not 1. This is 0. Sorry. This is 0. Okay. Upper limit is 0. No. Upper limit is 0. So I can take my sign outside. I'll get what? X is from where to where? Now please look. My integration I is nothing but my sign is outside over here. So 0 minus 1 by 2. Okay. Okay. 0 minus 1 by 2. No. Why, sir? Because this is minus 1 by 2. For that reason. 0 minus 1 by 2 will be what? Please check. This is minus sign outside will become plus 1 by 2. How much is that? Okay. Simply will be plus 1 by 2. How much is the answer? Minus 1 by 2. Minus 1 by 2, option number A. Okay, simple enough. For odd function, for this will be even function. Why, sir? So we have not taken even function as in, we have solved this and got the answer as this minus 1 by 2. Okay, moving on. Question number, I hope this was visible. Question number 6. Question number 6. Over here, same question, very same question. 0 to root 2 x square. Please check. I can break this function again. Why I am breaking this function like this? Because this function, what is this function called as? GIF, greatest integer function, is having critical point at what? At all the integral values. That's why I am breaking over here again from where to where. I can write this as integration I equals to what? 0 to root 2. Okay. This is my square of a number in the GIF, greatest integer function, with what? With dx. This is dx is missing. Chaliye. Okay. Now do one thing. Break this. Right from 0 to 1. Why 1? Because at integer value, the function has having critical points. So write like this. Okay. Again, what I'm going to do? From 1 to root 2. What's this going to be, bacha? This is simply what? X square dx. X square dx. Okay. Please have a look over here. On this side, the function will open with what? Between 0 and 1, it will open with 0, sir. Okay. So this part is gone. What about between the function? This will open with what? 1. So 1 is square in this thing. How much is that? Simply 1. Okay. Because from 1 to root 2. From 1 to root 2, it will open with 1 only. Because what is root 2? Root 2 is 1.414. Again, it will be 1 only. Okay. So this will become what? 1 to root 2. 1 to root 2. My I is 1 to root 2. 1 dx. 1 dx. What is that, bacha? Tell me. It will be simply what? My I will be equal to integration of this is what? Simply x from where to where? Integration of this will be x from where to where? Upper limit is root 2, lower limit is 1. What is the answer? Root 2 minus 1. Upper limit minus lower limit. Any option like this? Option number C. Option number C. Very simple problem. Yes. Okay. चलिए आगे बढ़ते हैं. Question number 8. Question number 7. Okay. Cos 2x ln sin x. Same question I think I've done in the previous session. Okay. I will give you some hint. But this is going to be a homework again. It's going to be a homework. So comment your answer. Comment the correct option. Correct options. Okay. Which is the correct option? You correct, let me know. Okay. Not option. You will have only one option correct. You will have only one option correct. Okay. So I'll show you how to do it. Then you can try and solve this. But I think I've solved the exact same question in the previous session. Okay. So I can write this integration I as 0 to pi cos 2x ln sin x. So I let, right? It means log is having preference over this. So I'll write this as 1. This is 2. I'll use what? I'll use my by parts rule. So if I use by parts, what I'm going to do? Keep this one as it is. So I'll write it as sin x. Sorry, not sin x. Ln of sin x. Okay, this is as it is. Please have a look. As it is. Alright. And this will become what? Integration of cos 2x is how much? Sin 2x upon 2. From where to where? From 0 to pi. This is my first part. My sign for the second part. Integrate what? Differentiate this thing. Will become what? Sin x cos x. Because I have done for ln x. Will become, for log will be what? This is my log, bacha. For log will be what? 1 by sin x. For sin will be what? Cos x. So cos x by sin x. And I'll what? Integrate this will become what? Again sin 2x upon 2. Sin 2x upon 2 dx. From where to where? 0 to pi. Okay. If you do this, you're gonna get what? If I remember, you'll get sine will be cancelled. Cos square x you'll get. You'll get cos square x. Okay. This will come as cos square x. Okay. Cos square x dx, you will get this as cos square x dx. Again, take it as 1 plus cos 2x by 2. 1 plus cos 2x by 2 you can take and solve this answer. Alright. Please solve this. chaliye, okay, moving on. I'm moving on. You have to solve question number 7. So question number, you have to solve for question number 7. I've given 2 options today, 2 questions, both on by parts only. I've given hints how to solve it. Please solve the questions and let me know. Question number 8. Question number 8. Find the value of the function from x from 0 to 1, x times of 1 minus x to the power n, okay, and the options are given like this: 1 upon n plus 1 upon n plus 2, 1 upon n plus 1 times n plus 2, and 2n plus 3 upon n plus 1 times of n plus 2, okay. So like right now, if you have to solve this question, how will you solve it? You have to use the binomial expansion. This cannot be true, because if you take the binomial expansion, it will become a little tricky. You have to do for a lot of terms. You will have to do for n terms. There must be some trick to it. Let's see the substitution now. Let's see the substitution now. So I'm going to take this function as 1 minus x equals to, let's say, z. I take it as 1 minus x equals to z bacha. I can take it, no problem. So now what is my z value then in that case? What is my x value in that case? My x value will be minus x equals to what? Z minus 1. Okay. So simply x is equals to what? 1 minus z. 1 minus z. Okay. Chaliye. Differentiate this. I'll get what? 0 minus 1 equals to dz by dx. Yes. So I get what? I get minus dx is equals to what? Dz. Simply dx equals to what? Minus dz. I have to change the this also, the variables, the limits also. So please check. Please check the limits. So if I am doing like this, if I am taking x equals to lower limit, x equals to 0, what's my upper limit? Check here. X equals to 0, lower limit. For z is going to be what? Z is going to be 1 minus x, simply 1. Please have a look. X is 0 for the lower limit. So z is what? 1 minus 0, so 1. For the upper limit, what is x? X is what? X is 1. Z will be what, bacha? 1 minus 1, how much is that? 0. Okay. Now change the function over here. So I get what? I get my integration I equals to what? Please have a look. Lower limit is simply what? 1. So 1 to 0. X is what? X is 1 minus z. 1 minus z. And what is 1 minus x? 1 minus x is z. So simply z to power n. And what is dx? Dx is minus dz. Dx is minus dz. So please check. Minus dz. Okay. Let's take this minus sign outside. I get what? Minus of 1 to 0. Expand this. I'll get what? Z power n minus z power n plus 1. Yes. Z power n plus 1. This is simply what? This is simply dz. Okay. Now do one thing. Integrate it. Bacha, integrate it. So if you integrate it, what are you going to get? Please check. You will get this as minus. If I do this, I get what? Minus. I can take the minus sign in the limits also, right? Please have a look. I can take this minus sign in the limit. It will become what? 1 upon 0. 0 upon 1 is the lower limit is 1. Upper limit is 0. I take the minus sign in the limit. It will become what? 0 to 1. So I can write it as 0 to 1 z power n minus z power n plus 1 dz. Okay. Please have a look. It will become what? Z power n plus 1 minus z power n plus 2 upon what? Whatcha? N plus 1 upon n plus 2. Please have a look. 0 to 1. Confusing? Please have a look. I have taken integration of z power n. Z power n is what, bacha? Z power n is z power n plus 1 upon z upon n plus 1. Same way, z power n plus 1 will be z power n plus 1 plus 1. So n plus 2 upon n plus 2. Okay. This is my same thing, integration I. Okay. Now let's substitute the value of the limits 1 and 0. If I put 1 power anything will be what? 1 only. So I'll write it over here first. I will be written as z power n plus 1 upon n plus 1 minus z power n plus 2 upon n plus 2. From where to where? From 0 to 1. Please check. I'll put the value of z to be 1 first. I get 1 power n plus 1 by n plus 1 minus 1 by, again same thing, n plus 2, because 1 power anything will be what? 1 only, no? And when I do for 0, I get what? Simply both 0 and 0. How, sir? 0 power anything will be what? 0. Same thing here also. So anything divided by 0 will be what? So anything if you divide to 0 will be what? 0 only. So I can write it as 0 0. No problem. So I get I as, please check, 1 upon n plus 1 minus 1 upon n plus 2. Check the LCM. Please check the LCM. LCM should be what? N plus 1 times of n plus 2. What is this? N plus 2 minus n plus 1. How much is that? So simply n plus 2 minus n minus 1 upon n plus 1 times of n plus 2. This and this goes out. I have 2 minus 1 as 1. So my integration I looks like this: 1 upon n plus 1 upon n plus 2. My final answer. My final answer. Any option like this? C. Option number C is correct. Please have a look from the beginning. What about this? Simple enough? Okay. Moving on to the question number 9, the last question for the day, last problem for the day. Okay. We'll complete the properties of definite integral over here only, and in the coming sessions we'll see and solve the revision for the integration. Okay. And we'll complete this chapter. Chali. They have given here as f of a minus x is equals to f of x. This is given condition. Also they have given g of x plus g of a minus x is 2. They have said that I1 is this thing. They have said that I1 is equals to 0 to a fx dx and I2 is equals to 0 to a fx gx dx. So let me write the I2 part first. So I can write this I2 as integration from 0 to a f of x g of x dx. F of x g of x dx. Okay. Now I would like to replace in the x, okay, in the x a minus x, because you see here f of a minus x is known and g of a minus x also have a relation with gx. So I'll replace this sub x as x equals to, I'm taking this as my equation 1. Okay, first of all I'm taking x as what? A minus x. Substitution is there, a minus x. Okay. If I do that, what I'm going to get? Bacha, tell me. I'll get this as, can I do it like this? Any property? Please check. Some of the limits, 0a, 0 plus a, minus what? The variable. What is this? Simply a minus x. If you don't want to use this property, you can do the way we did for the previous questions. Okay, you'll get the same result because the minus sign will come and again the limit will be interchanged. Okay, but if you don't want to, use this property directly for the limits. Okay, so I can rewrite this condition I2 as from the property number 7. Now the property number 7, 0 to a, the limit will remain unchanged and the function will be changing the variable from x to a minus x, g of a minus x. And what will this be? Tell me. This will be simply dx, simply dx. Okay. Now we have the function f of ax minus value, f of x. I have this f of a minus x is f of x. So replace this here. So I get I2 equals to 0 to a f of x g of a minus x or not. Please have a look. F of a minus x is equal to what? F of x. So I wrote that value. Okay. Now take this as my equation number 2. Please add 1 and 2. So I2 plus I2 will be what, bacha? Simply, sir, 2I2. Equation 1 and 2. 1 and 2. I2 plus I2 is what? 2I2. What about this? Limit is same, right? 0 to a. So right here, limit is same, 0 to a. What is this? F of x gx dx. So f of x gx dx plus, I can take dx outside, no? I can take the dx outside, plus, what is this? F of x g of a minus x. So f of x g of a minus x, and this whole thing is with dx. Okay, chaliye. F of x is common. Please take this common. I get what? 0 to a. F of x is common. So I write it as f of x. Okay. What I'm left with over here? G of x plus g of a minus x or not. Please have a look. F of x is taken common. G of x plus g of a minus x is there. Okay. Chaliye. Now what is this condition given as? G of x plus g of a minus x is what? Simply 2. Simply 2. Okay. So next step I'll write it over here. First let me write the same thing. I'm getting over here as 2I2 equals to same integral limits f of x times of g of x plus g of a minus x with what? with whole thing as dx, with whole thing as dx. Same thing written over here, gx plus g of a minus x dx. This is nothing but 2. Please check. This we got it as f of x. This we got it as 2 dx. Okay. Take this 2 outside. I get what? 2 times of 0 to a f of x dx. Isn't this nothing but 2i1, sir? Please have a look, sir. What is I1? 0 to a fx dx. 0 to a fx dx. So 2i1. What is this condition? 2i2. So cancel this. What's my I1 by I2? Is 1. Option number, they ask for I1 by I2. Option number 1. Option A is correct. They asked the ratio of the two integrals I1 by I2. Okay, we got the result to be 1. How did we do that? We use the second integration, change this value using the property number 7 that we had, okay, by f of a minus x and g of a minus x. Why did we did that? Because the values of the f of a minus x is known in terms of f of x, and there is a relation for g of a minus x. We use that to get this result and get this ratio of integrals to be 1. I hope this is simpler enough. Please have a look. Visible here also, it's visible. Okay, so I hope this was very fun, short session, not that much is there, and very simple concepts. I do have given homeworks because those questions I've done exactly the same in the indefinite integrals and also in the definite integrals of previous sessions. So this concludes your integration. This concludes your complete integration. All the properties, all the different properties, all different types of questions, formulas have been discussed in this session. Anything if I have missed out, comment in the section below. Let me know, sir, this part is missing. I will come up with the session on that. Okay, no problem. I can also miss something sometimes. So comment in the section, in the comment section, and let me know what is missed out. I've tried not to miss out anything, but if there is, let me know. One more thing, there will be a revision session of I think 2 to 3 sessions. Maybe with PYQ it might become 4 sessions. So we'll do all of the 3-4 sessions to complete the revision of all the different type of integration that we learned. Okay, different type of questions that we can solve, and we'll do a PYQ session also. We'll solve a PYQs also in one session. Okay, so this will conclude the session today, bacha. I hope you enjoyed it. I hope you learned from it. Okay, I hope this was helpful. That's the main goal, right? The session should be helpful to you. So that is it for today's session. Keep working hard, keep smiling. Take care. Bye bye.